Welcome to Module 2 FMEA Concept for Railway Industry. In this module, we introduce the main concept related to FMEA. It presents also the templates concepts that we apply during the FMEA workshop, as well as present some standards. Before starting the training, whenever we are located in some facility, we need to be sure about the emergency exits. So that's apply whenever we ECC provide the training, we introduce these slides and ask for the facility owner to speaking about and clarify about the exit, the emergency exit. Okay, so that's just a reminder. Let's start our FMEA concept model by defining the different type of FMEA. Okay, so the FMEA basically has the main objective to understand the equipment failure, their cause and consequence, as well as take into account the recommendation to avoid failure and consequence. So that's the generic concept, and we can apply FMEA during different phases. That we will see that's in more clear examples in the next model. We always face the two different names such as FMEA and FMECA, and when we have the C here, that means criticality. So failure modes, effect, and critical analysis have the same concept that we have in FMEA, but with a criticality aspects. In this criticality, it's so-called RPN number, risk priority number. So we had a chance to see further during this training a real case of FMECA, and by now it's just to understand what this risk priority is about. Is a risk as a critical assessment that takes into account the cause, consequence, and detection. So for each one of such factors, such cause, consequence, and detection, we have one range of values that we apply. In the end, we multiply both these three values in order to have an RPN number. We discuss in details about the RPN number in the next models. Okay, design FMEA is a FMEA applying during the design that has the main objective to identify the failure modes and cause that is triggered during the design phase, which can have a consequence and impact in equipment and system during operational phase. And that's the usual early life failures that's triggered by a wrong design. And basically, this cause of these early life failures triggered during design are material quality and poor specification. Okay, so process FMEA is another type of FMEA, and the main objective is to identify the failure modes and cause triggered during manufacture phase with the consequence or impacts in other equipment and system during operational phase. So different from design FMEA now, the process FMEA, the main cause and failure modes and cause are triggered during the manufacturing process. So we need to pay attention, and whenever is necessary, whenever is important to consider the manufacturing process, assembly, montage, we implement the process FMEA describing its process manufacturing phases, equipment, and which kind of failure modes can impact on it on product quality. Okay, so most of the cases failure cause is related to manufacturing process or assembly quality and poor specification. And we are, of course, have the RCM. This is the topic that we'll be discussing during the second day of this training, but just to have it clear that RCM means reliability-centered maintenance, and the main objective is to define the best maintenance policy and task based also on reliability and additional data that we have historical failure data to define the frequency of the maintenance, preventive maintenance tasks, and cost, as well as cost specification, and that's all based on specialist opinion as well. So definitely is very important to go through the FMEA first before to carry out the RCM. We also see this example during this training, and we had a chance to see how effective is to implement the RCM after the FMEA. Okay. When the FMEA starts, that's a very important question. So let's just understand when the FMEA starts. So the FMEA, just a brief introduction about the FMEA history. So the FMEA starts with U.S. Armed Military Force. So in U.S., we have this military standard. So one specific, that is the military standard P1629, is related to FMEA. That was one of the first failure modes standards that enable implementation of FMEA in a military industry in US. So after that, we have in 1960s contractor for US for the National Aeronautical Space Administration also signed to implement FMEA and FMEA in their projects. We have also the Society for Automotive Engineers publishing the ARP 926 in 1967. Other standards, now we have updated standards by the Society Automotive. We have also the U.S. Environmental Protection Agency implemented describing the application of FMEA for water treatment plants in 1973. And then again, the automotive starting in 1970 with the Ford company implemented FMEA for apply safety regulatories. In 1993, we again have now the Automotive Industry Action Group that has his first publication of FMEA for automotive industry. And Toyota again is benchmarking for process and management process has also implemented FMEA. That is so-called design review based on failure modes analysis. There's very good practices that's describing how you implement your design review after you have a FMEA failure modes analysis. So we can see that FMEA is a type of methodology applied for a different industry, also for railways. Railways was one of the last that's starting to describe their run programs and also each reliability engineering methods, including the FMEA and RCM. But based on such standards and the previous standards, nowadays we can say that the FMEA is clear for many consultants companies as well as railway industry companies, and then it's not a big issue to apply that, but we need to clarify the concepts and the application along the safety life cycle. Okay, so railway industry also apply FMEA that we're going to see examples in here. Mostly is in most of the railway projects is one of the analyses always implemented, and because of the valuable information and output that such analysis give and enable to develop and improve the product design. Okay, so a type of failure definition, that's a very important concept because in many cases we have different specialists or reliability or maintenance or safety or even operators discussion about the type of functions, and we need to clarify what these terms means. We need to also understand that for FMEA point of view, you will define we can start in the system level, but also in product level, we will have the failure mode for the components and or the general failures for system. But in any case, we will have the failure modes as the main definition. Okay, but we again we can have different definition about the failures. One of them is functional failure, and that means when the equipment meets the main functions. Okay, and we need to be aware here that the equipment can lose 100% of his function or something in between 0 and 100%. But whenever we are trying to get the most from FMEA analysis, we consider worst case, then we consider that the equipment lose the 100% of his function. So he's not available for fulfill his function, and that has an impact on the system. So concerning the train, we can have different systems that will have a huge impact in a train availability if such systems such as wheels, brake, pantograph, doors, TCMS, or propulsion system have a functional failure. Okay, it's very important to understand that some of such functional failure can be an unsafe failure. Unsafe failure happen when the equipment operates on unsafe condition. So, for example, if the brake valve failed closed, so if it failed closed, it's not possible to manage the brake, and then we can have an accident. That's the kind of unsafe failure. Unsafe failure is related to a failure that causes unsafe condition that can trigger an accident. And we have a lot of them. For example, in Bogie, if we consider the wheels or the axle or even the bogie structure, if you have a fracture, we can have a derailment, or and that's the unsafe failure. So many type of functional failures, or failures that's not functional but are failure modes for some equipment. Functional failure concerning components level can be unsafe, and we need to be aware about that. And when we are not responsible for safety discussion, we need to shift such information for the safety engineers. Okay, we have also the so-called hidden failure or occult failure. Rhythm failure is not detected as discussion before. So in some cases, some rhythm failure can also be an unsafe failure. So for example, a fire sensor failed and is not able to detect any more smoke. So it's necessary to check and to find out such failures in order to have the system available. Otherwise, we can have a fire initiation fire, and in case of the sensor is not working, we have the consequence of that. We have failure on demand, and this concept of failure on demand is applied for standby components or a component that has a functions to be replace some equipment or act in some specific condition. So we can have the WTP cables along the wagons, and we will see that in some cases some of them are redundant, and we can have failure on demand. So we have two cables basically. So whenever we need the next one, when the main cable failed, what's going to happen is if the standby is failed, when is demand is not operated. So that's a so-called fail on demand. Okay, we have common cause failures as well. So this is also another very common concept that is discussion mainly applied to safety issues. So for example, two or more equipment lost part or total functions due to similar cause. For example, if you have no electricity energy, if you have electricity energy shutdown, that's affect motor in a different bogies, because we not have supply for energy that comes from the pantograph and go through this system, this energy system, proportional system. Okay, so that's different type of concept. We need to be aware what does it means. So whenever we have a discussion during the FMEA or other meeting, we'll be able to understand what it's about. So here we have an example, a picture of the pantograph. So if this pantograph lose their function, no matter what components cause such a pantograph loss of its functions, there will not be the collection of energy that go through the pantograph to the motor, and in the end that will affect the train. So as a discussion before Bogie, we have many related unsafe failures that's related to some of their components. So for example, in the Bogie structure, if we have a fracture, we can have a derailment. That's type of Bogie unsafe failure. So we need to take into account that during the FMEA analysis and shift such information for safety engineers. It's very important to understand that in some case the FMEA analysis application is focused on operation as well as maintenance objectives, and not concerns the safety issues. That can be done, but if it's not considering safety issues, the further FMEA need to apply for to consider the safety issues. So it's very important to not forget the impact about the safety that some railway system has, and in case of some failures that can be real can have a real impact on safety. Okay, so WTB cables fail on demand, so we have redundant cables. So we can see here the WTB cables. Here we have two. We have this WTB cable, or even the Ethernet. Here we have one here and the other one here. So that means, let's take an example of the internet here. If this one fail, we can shift to the second one. But let's take into account that the second one is already failed. It's a read-and failure that was not test carrying out, and then this cable here that's supposed to be the standby for the first one is already in a failed condition, has already a functional failure. So when that failure happen, when I shift to the other one and demands the standby one will be in will not take place. The main cable functions because it's failed. So that's type of fail on demand when we request some equipment to operate and that's not working. Okay, so that's the concept of fail on demand. FMEA applications, we need to understand why you apply FMEA and what is the application of FMEA. So we have different applications. So the first point is what we can do to prevent and what's a recommendation that we can provide to prevent some failures. And that is important to identify the potential failure modes or for a product or process. And that means during the design FMEA or even a process FMEA, we need to identify the potential failure mode and causes to prevent some failures, to put some recommendation on it. Okay, so FMEA also enable to provide a risk assessment. So based on a failure mode concerning the frequency of occurrence, severity, and detection, we are able to prioritize different failure modes in terms of risk or even criticality. So risk, we'll take a look on it further. Risk is a combination of frequency and severity that can be done quantitatively or even qualitatively, that is applied during FMEA by a risk matrix, or even you can have in a FMEA as described before, we can have the RPN number. We see that in details, but basically the FMEA provides this risk assessment. So in the end of the FMEA, we will have for each failure mode, we will have some risk assessment that enables to rank and put some prioritization to implement the recommendation to mitigate the risk. So basically, in the risk concept, we start from the highest risk level, decide to mitigate from the highest risk level to the lowest risk level. That's the general concept. We have a module to discussion about the risk concept, and you understand it better. That's a further one. But it's important by now to understand that the FMEA provide a risk assessment. You're going to see a template and you see how is applied in a FMEA template. For the RCM analysis, so RCM is all about to describe and to define the maintenance test, preventive maintenance test. But it's very important to know what kind of failure modes are linked with such maintenance tests to have a proper maintenance task related to such components. And that's also a why to put a lot of recommendation that will not enable and that will enable, of course, to prevent failures, but in highest cost. So the support for RCM is a very important point that we apply with FMEA. Driving quantitative accelerating tests. So since we are clear, understand what's the failure mode cause and effects, and when we are discussing about the failure mode cause, we are talking about also about the physical of the failures. We are able to focus in the test and define which are the accelerating factors. That means the physical factors that cause or accelerating the failures that we need to put in our test. So just a brief explanation. When we apply tests during the design, we have functional tests that has the main object just to test if this product have this product function operate as is intended. But we can also apply the accelerating test. Accelerating test puts the components in such condition, hardest condition, in order to provoke that failures happen in a short period of time. And depends on the objective. If I want to predict reliability, I have the quantitative accelerating test, and I capture the time that the failures happen and predict the failures in an operational condition. And I can also have the halt test. The halt test go through a higher limit of stress, and provoke that failure happen in shorter period of time. And also new failure modes can happen and enable to not only develop the products but to develop a robust product and to know unknown failures that can happen in a very extreme condition about the products. Okay, so the failure modes will be the first step that will clarify the failure cause and the physical failure that can trigger. And based on this design FMEA that we apply and consider the physical failure, we are able to define which are the stressor factors that we are using during our accelerating tests. Okay, and that will be the same for the reliability growth. And since we is also part of the test, so but the reliability growth is after the test result, you measure how is the increase of reliability related to the actions, improvement action that was implemented in the previous phase. And then you're starting to measure after each improvement action until you achieve your reliability targets. So it's very important, it's similar concept that's a quantitative accelerated test. You need to define to understand the physical failures and the accelerators, the stressors factors that we implement that will trigger the failure. For example, the temperature, consider a sensor, the temperature and the voltage are the two physical factors that trigger many of sensor failure modes, such as short circuits or open circuits, for example. Okay, so such a female the failure modes analysis, the design, in this case, the design FMEA, we enable to have some setup for this test to define the stressors, and that will drive the test to have the main results linked to what we expect to have as a failure mode and quantifying that. Okay, so that's our the FMEA application. And in order to apply FMEA, we need to get some inputs as we have in different analysis. So we need to get a draw if we have a process or equipment that we can have a clear picture about the equipment. We need to have equipment list. That's a very critical point during FMEA applications. So in many cases, we sign the FMEA before getting to such equipment list. And in some cases, the company do not have the equipment list, or there is not finished is during the design. And what's happened is if we forget some components, we need to review the FMEA. So in order to avoid to review and do again and again the FMEA, we need to have the equipment list that describe all the equipment and components that are under the FMEA scope, and that will enable to reduce the rework related to the FMEA. Of course, during the design, we can have a modification and we can update the equipment list. And as long as the equipment list is updated, we will need to update it and check our FMEA. Okay, so historical failure data can support as well the FMEA analysis. That's not usual to have historical data to support a FMEA or have the attendees of the FMEA workshops, such as maintenance or operators technician with such information. But as long as they have such information, that will help a lot, because enable to have a more precise assessment of the frequency of failure mode cause concern the FMEA. But of course, not a quantitative analysis is not real necessary, but that gives some basis for the specialists to estimate the failure frequency for each equipment. Experienced operators and maintenance technicians, they know precisely the frequency of such failure modes, but if we have historical data and if company has some reliability database that can give such information, that will be perfect. Okay, participant list also additional information, very important information that you need to have FMEA. After to finish the FMEA workshop, it's very important to assure and provide provide the information and to guarantee that the competent people were took part into the FMEA workshop. And these FMEA reports and results are a result of different specialist opinion, and that is assured when we have the participant list. We can also have additional data like such as project data or even other analysis can support the FMEA as well. But usually you need to have updated project data. So basically PIGs project or draws for equipment that will support a lot to identify the type of equipment or even to clarify such information. And in the end, we will deliver FMEA reports, and the FMEA report must list all document that was used during the FMEA workshop and need to have the participant list concerning the specialist that was took part into during the FMEA workshop and need to consider the assumptions, the critical failure modes, all the list of recommendation, and so on. The FMEA needs to answer 7 questions. That's very important. When we carry out the FMEA, sometimes how we are going to know if this FMEA fulfills the main objective. So if you answer the 7 questions, that will be great. So the first question, what are the function and associated desired standards or performance of physical asset in operational context? So we need to understand the function, not only in system and equipment level, but also in component level. In what way can it fail to fulfill its functions? So functions failures. Functions failures is not a point that you have a big discussion. Since we have clear what the function of such equipment components are, we know that in case of partial or total loss of such function, we have our function failures. But the main issue is what causes its functional failure, and those are the failure modes. So it's very important to define clear the failure modes. We have standards available to check. There are a lot of standards as I mentioned before, and you can look on such standards or even in books or internal documents. The point is you need to standardize the failure modes to use and define well to use during FMEA. And then you need to clarify what's the cause of those failure modes. Another question you need to answer in your FMEA. And the cause is very important to be clear in this cause definition. In some cases, you can go deeper and define the physical of failure related to each cause. And that's enabled more precise recommendation, prevention of such failure. Such physical failure is very important basically for the design failure modes that you need to define the stressor as discussion before. But as long as you can define that, it will be great. Your FMEA will be more clear and the recommendation preventive actions will be clear why it needs to be taking place. Detection is also another very important point, and mainly when you intend to implement RCM after the FMEA, the detection, classification, and definition will be very important. And how can we do to prevent the failures, the recommendation? Then some recommendations are based on design review, some recommendations are based on tests, and of course some recommendations are based on preventive maintenance, because we need to be in mind that this failure is going to happen. What we all try to avoid that such failure happen because of some design or manufacturer failures, or even commissioning or installation. But the components will fail. What we want is that the fail happen in expected time and based on the normal condition. And then to prevent such failures, we need to implement some preventive maintenance. That's all the focus of the RCM discussion, to define which kind of preventive maintenance can detect or avoid the failures that's linked with such component failure modes. And that will be the first step. But concerning FMEA, if we just recommend something regarding that you need to make assessments concerning preventive maintenance, that will be great. Okay, so if we are able to answer these 7 questions in our FMEA, the FMEA is well done. We can consider that. So FMEA have the methodology steps that need to be followed. The FMEA analysis by itself is not only the workshop, is not only the report, is everything. And it's starting with defined system hierarchy and also the scope of the FMEA. That needs to be clear and defined. And the documents will support such hierarchy and the scope definition, because in equipment list the documents or even in PIGs or drawing documents, the system is very clear defined. And since when the equipments are well defined, the scope is well defined, we will have our selected equipment and components. And then when we have that, we can start our FMEA. So basically, we have a workshop, and we invite different specialists to be part of this such workshop, and we implement a FMEA analysis. So FMEA analysis, we use some templates and we assess each equipment and components level, or even if a system FMEA system in a high level, we for each one of such a physical asset will define the failure modes, the cause, the effects, the detections, and depends on the scope we apply a FMEA or a FMEA. The FMEA, after that, we of course we define some recommendations, and the main issue, the main point in the FMEA is to implement such recommendation. So we need to have a plan. We need to manage such recommendation. That is about the step 4. Since the recommendation are defined with responsibles and with the timeline, and we need to follow up, and then we need a task and a plan to follow up such recommendation implementation. That's very important during the design, because after the design is finished, there is not more space to make any modification, and it's the cost of modification will be higher, and will cause also delay in the project. And mostly the project manager will not accept that. So we need to manage the recommendation implementation. That means we need to sometimes have interface with different departments and need to have a manager involved on it in order to be sure that such recommendations are implemented in the proper time, okay? And then to do that, we need a plan, and we need to follow up all the tasks and have regular meetings, and to be sure that such a recommendation implemented. So implemented recommendation task is very important, and in some cases recommendations are very general defined in a FMEA analysis, but need to sometimes that will need some subtask in order to achieve such a recommendation defined in FMEA, and that's a task of each department, and each manager responsible for their department to define such subtask to provide the proper resource to implement such a recommendation. And in the end, we have a report. Of course, the reports happen after you finish the FMEA that have such recommendations, but you need to review your FMEA as whenever you have a new design modification, whenever you have new components and some issues, safety issues, for example, arise, some issues from safety analysis arise in your design, you need to review your FMEA. So you need to be aware that the FMEA review is part of the FMEA. So that's very important point for the design when we are planning our FMEA, our RUMs in program implementation. We need to be sure that the FMEA are divided for different phases, such as design, manufacturing, and operation, as well as during one phase you need to review more than once your FMEA if there will be some modification in the design. Mostly you do not review everything that you written in the FMEA, but some specific point. But you need to be aware that some review are necessary, and that needs to be clear for project managers, because they will provide resource time to do that, and they need to know exactly and how you estimate your reviews, how many reviews that will be, how long does it take, and how many specialists you need, because the project manager manage all the resources for a project, of course, and that will impact in the deadlines, in the gates of the project phase, and so on. Okay, so the FMEA is not only about analysis, not only about applying software, it's not only about a workshop. You need to consider also the recommendation implementation, and that needs to be done in a proper time in order to have the effectiveness of recommendation implementation to improve the product design and avoid the failures along a set life cycle. Okay, so let's take a look on a FMEA template. A FMEA template you can do in Excel. This is an example that you can apply in Excel. You have the title here, failure modes and effect analysis. You have the leader name, and here you have the dates, the project, system, subsystem. You can put the component or equipment or component list in here is very important, and here is the most important parts that you define the documents and the version of each document that you use in your FMEA. And here, of course, you put the participant list. Of course, you need to have a list with the signature of each participant to put on your report in the end to demonstrate that your FMEA was carried out based on different specialists' opinion and they aggregate information. That was a consensus decision about the recommendation. Okay. In the second part of templates, the FMEA by itself, you have number of lines, you have the equipment number. So, for example, if you have a pump, probably you have J2101, that's the tag of the pump. You have the equipment description, so it's a centrifugal pump, for example, or in case of the railway, you can have parts of the brake, a cylinder, or even a pad, or a valve, a safety valve, so whatever. You have to define the equipment functions, and then you go to components number, the components, if they have some tag, you put in here the component functions and the failure mode. So here an example of template that you work in equipment components level. Okay, for each component there will be different failure modes. For each failure mode you can have one or more cause of such failure modes. For each one of such cause you need to put the phase that such cause happen, and that's very important because the recommendation will be related to the phase that failure cause happen. And then based in this failure cause, you apply some frequency based on a risk matrix and detection of this cause, if it, how hard or easy is the detection, also based also in a classification. We'll see such risk and criticality classification further on in the next model. Then in a railway, it's usual that you put local effect and system effects. If you're discussion about a locomotive, you put the system effect means effect in a locomotive. And if you're discussion about the train, the system effect means the train effects. And then the severity means the consequence, related consequence, what the classification of the consequence. You can have a general severity, or you can have a specific severity for concerning people or environmental or physical assets and so on. And in the end, you have a recommendation. Okay, so this recommendation try to mitigate such risk, and then you expect to have a lower risk here. Usually, you improve your frequency or you improve your detection. The severity, if the failures happen, there will be basically the same consequence, and that will be the same severity unless you change the design or replace for a new technology. And in the end, you have your RPN number in here, the new RPN number of a modification, and based on it, this RPN number, you follow up and you prioritize your recommendation implementation. So it's time to implement the most critical one. Some of them can be unacceptable, then you need to implement that. Okay. So here we can see the FMEA sheet data description. What is the system as a group of subsystem that's together carry out a specific service. So we can have the Bogie, and in this Bogie we can have the train system, but you can consider different subsystems such as a Bogie, brake, Pantograph, a propulsion system, and so on. And a subsystem, a group of equipment that together carry out a specific service or make some products service. For example, if you have a brake, or even if you have, let's see, a Bogie by itself is a subsystem, but Bogie is encompass different equipment such as the wheels, the axles, the Bogie structure by itself, the bearing box, and so on, or even the brakes. We can also have the brake system, but we have the cylinder, we have the lines, we have the pipes, we have the valves, and so on. So it's a description of subsystem. The function is a system, subsystem, or equipment, or even component main objective. So different equipment or components have different functions. Maybe some case we can have more than one functions. Usually during the FMEA we concern the main function of such equipment or components, and based on this main function we define the failure modes. It's very important to be clear about the functions. Some specialists have different understanding about the equipment function, and when we describe the function of the FMEA, that's enabled that everyone has the same understanding about the equipment function. The Failure mode is the way that some equipment lost partial or total functions. So different equipment have different failure modes, of course. So, but we need to be clear that when we have this blank failure mode, we cannot write only equipment or components defected. If we can assign some failure mode, specific failure mode. So depends on the components, we can have different failure modes. In case of Bogie structure, for example, we can have a crack, we can have a corrosion for or for different components in general. Of course, we have different failure modes. We see a specific failure mode for each equipment components when you demonstrate a case studies and further on in some slides. Okay, and of course, for each failure mode, we need to define cause, root cause, or physical failures, and the reason that's explain why the failures can happen. So wear outs caused by bad material quality, bad assembly, or even by high temperature or high pressure, high vibration. So such of those cause trigger some failure modes in equipment. Okay, and then you go further. You need to define in your you have some definitions, some lengths that you need to put a consequence, the impact of failure modes in systems, subsystem, or equipments. And as I mentioned before, you have consequence on local effect or even system effects and train locomotive level. You can define the detection, the way the failure modes is detected or the cause of failure modes detected. You can have a visual or auditive or even by test. In the end, you put some recommendation. That's the aims to prevent such failures and avoid a consequence. Okay, or even improve the equipment in case of the design phase. And then you have frequency, severity, and you have again the risk, mitigated risk after the implementation of the recommendation. So here, in some cases, we are always discussing what is the best to apply or implement the FMEA software or doing Excel. Okay, so here is an example of the FMEA that we can apply by using the software. Here is the FMEA, the RCM software from Rely Software. We can apply the FMEA as well in here, so you can see for a fire detection implemented in a train that you have the smoke detector. So the detector have the functions definition, the loss of functions, the effects, local effects, severity, cause, and so on. So we can define the different classification for severity and occurrence and so on, and that's enabled to have a database. When you use the software, in the end, you have a reliable database. You can apply and enable for different users in different levels, so people can make modification or people can only read that. But the end, for companies that have many projects and you need this information further on, is a good decision to have a database, FMEA database, that you can use the previous FMEA and reduce the working hours doing again the same failure modes analysis for the same system. Of course, you need to be careful with modification, the difference that system have, but if you have a database, that will be easier for sure. And also link different people in different locations around the globe, and that's people will be able to access the same database and carry out their analysis such as FMS. So that's the advantages to have a software. Of course, if you have only a single case that you implement FMEA for a system that will be once, you don't need to invest and apply a software for that because it's not your intention to have a database. But in case of you want to have a database, you apply FMEA for many projects, you have similar FMEA, it's good to have a database, so it's a good decision to have a software. Okay, FMEA you can, as I mentioned before, that's starting in an aerospace industry, but is applied for different industries. So we have different FMEA standards. I just put some example here. We have this standard 60812. This one updated FMEA standard that we have that was released in 2006. We have the SAE J1739 in 2009 as well, updated one, very good standards for that describe design FMEA and a process FMEA description. So you can use such standards if you have some doubts, or if you want some guidelines to define FMEA in your company, or even if you want and intend to write your own company procedure related to FMEA, so you can get these standards and as a reference. Okay, so thanks for your attention. That's just an introduction and concept about FMEA. And the next model is trying to go in more details, and then you'll be able to understand deeply the concept behind FMEA. Okay, so thanks a lot. If you have any question, just send us an email.